Hi everyone, welcome to Math's Spellbook. I'm your host, Peter. So basically we are going to continue on with a bit of proofs today. So basically what I have planned for today's stream is, oh, I probably should change the... Oh, thank you for the follow, Bipen Yantan. Hopefully I pronounced that right. So, actually I should change my title actually, because I think I didn't change it. So, proof, and we'll put vectors and tensors, because I actually want to get into a little bit of calculation-based math. So, thank you for the follow, Lipe. Hopefully like I said, hopefully I pronounced that right. So let's get right into it, shall we? So we're just gonna do Oh no, I did not. I basically have two. So I'm guessing you followed me on like, oh yeah, now I remember. You followed me on like my other channel. But how are you doing? What's the best part of your day so far, Lipin? I was kind of confused. No, I have two Twitch accounts. I basically use this one for like production streams. So if you feel like you have a little project you need to do on the side, like, you know, I'm just basically the person that will be your background noise, or I guess productive noise that you need to basically like get you in the productive mood, whether it be like doing things on your computer or whether it be like just doing chores around. Whatever it is that you need to do. I repair my phone? Nice. That's good to hear. Always good to have, like, your phone back. Yeah, so basically, on this stream, I usually just do math. Hopefully I get into doing some physics, too. So, basically, I try to be productive for my hobbies. And basically, my hobbies here are just math and physics. So, if you have something you need to do on the side, like, I hope I can be the good background noise for you while you're just trying to be busy, just being awesome at what you're doing, whether it be a hobby or whether it be just work-related. So I think now we'll just try to tackle this proof here in front of us. So, I will reread it. Actually, so here's how it's gonna go. I'm just basically going to try my best to solve this proof, and if I can't solve it, then I'll just go into Math Sorcerer's, like, solution to it, so. And, don't worry, you guys won't hear anything. I don't have anything to watch, so I'll just watch. Okay. No problem, no problem. Hopefully, me just, like, pondering on the problem doesn't, like, preoccupy you. But anyway, I've spent too much time yammering. Let's just get into it. So, we'll start the study timer, and let's just get into starting the proof. And I will talk to you guys on the side, so you guys can still talk on chat if you want. And I'll just get to your chats, like, momentarily, if I'm not if I'm not too much deep in thought. But usually for me, like, when I see you guys put something up, I read it out, and then I just get to it as soon as I can. Okay, so the proof we need to, so the question we have to solve is, let A be a positive number, prove that if X is a real number such that the absolute value of X minus A is less than A over 2, then X is greater than A over 2. Okay, so we wrote that suppose that A is a element of the real numbers, real positive numbers. So such X is an element of the real numbers such that the absolute value of X minus A is less than A over 2. Okay. So now the question is that how do we go about solving this? What's the first step here? Well, we can't use induction because what another math streamer told me, Penn Center. He's actually streaming right now. I think he's doing linear algebra with his stream. So, because what he told me yesterday is that you can't use proof of induction with this proof. Because it revolves around the real numbers. At least that's according to him, of course. And I'm taking his word for it because he knows more math than me. So who am I to give my opinion on that? So if we can't do proof by induction, we have the other techniques. So Bernoulli's identity. Oh well, actually we already wrote down Bernoulli's identity. Prove that 1 plus A to the nth power is greater than or equal to A plus NA for all of A greater than or equal to -1 for all n is the positive integers. Let's see how they did the proof here. Maybe that will give us oh yeah, they did it by induction. I forgot about that. So what else do we have here? We have the triangle inequality. I don't know if that will help us though. Will it? Because we do have absolute value symbols. Maybe we have to try to get the triangle inequality with like a negative sign or something. Because the triangle inequality normally is less than or equal to A plus B. Okay. So our conundrum is, so we'll just put triangle inequality. We'll put TI for triangle inequality. So what we have is this. So do we have to solve this inequality? So, in order to solve it, we have to do this. And then, oops. Then we minus a on both sides. Oh, oops. That's supposed to be a negative a. Let's just drag this. Oh, nope, nope, nope. Yeah, I got it. I got it. Then a minus a squared. That would make it negative. Yeah, because then this will turn into negative, and then, yeah, so, yeah, that's about right. That's right. And this side, this will turn into negative a 3a. So let's look at the proof again. I just want to make sure here. So let a be a positive number. Well, it kind of technically turned into a negative number when we did the inequality. Prove that if x is a real number such that then x is greater than So solving the inequality gets us to about here. I just want to make sure I did the arithmetic right. So minus, yeah, and then we have to do multiply by 1, and then that will lead us to boom, boom, with, oh, oops, erase that. Yeah, and then there'll be 2 minus a, right? Yeah. Yeah, so the arithmetic's right on there. But it turns out that the way it looks like x is a negative number. Oops. Let's drag this up. Because x is supposed to be greater than a over 2. Huh. I mean, I don't know if we're doing this right. Because they say a is supposed to be a positive number. Oh, wait, I did this wrong. Oops, oops, oops. It's not supposed to be minus, it's supposed to be plus. That's why it was funny. Okay. So we'll erase this part. Lucky I looked it over. So this would equal, right? And this would equal, okay, so now we're getting somewhere. Now we're getting somewhere. This is where we needed to be. Okay. Which is, oh, okay. I see where you're getting at. So let's say let let a be a positive number. Prove that x is a real number such that the absolute value of of x minus a is greater than a over 2, then x is greater than a and a half. Oops. And yeah, I guess we just proved it, because a minus a half, a over 2 is less than x, and x is less than x is less than 3a over 2. So we just proved it. Right. Okay. Okay, so okay, so we really didn't need this. I think we just did it. Yeah, I think we just proved it. And actually, this is kind of low. I should bring this up a little bit. So we'll just circle this, and then we'll drag it. Oh, nope. Circle this, and then we'll drag it up a little bit like that. Okay. Okay. This is a bit low, so we'll just... Hey, Sensation, how's it going? Let's see, 仕事を始めたばかりなんだ。What is that kanji in the front?してくれるよ。今ちょっと調べてる。勘弁してくれよ。Oh man. 勘弁。Okay. よく日本語してるのね。あまり漢字覚えてない。もちろんさ。そう。ちょっと日本語、練習してくれる。練習してくれる。久しぶりなんだ。話すの。Yeah, it's been a long time since I spoke in Japanese. So now I'll remember that kanji since you said it. Kampenしてくれよ. Hopefully work is not beating you up too bad. But how you doing, Sensation? How you doing? What's the best part of your day so far? Yeah, so I think we just solved this proof then. Because we actually did show that a over 2 is less than x. So how do we sum this up? Oh, I have to click on my tablet so that way it remembers to track my pen. So I think we just did it. I think we just solved this. Unless the proof is completely wrong. But I don't think it is. Because, I mean, yeah, we take the absolute value, yeah, move that to the side, and then we add it. We add the a, not minus the a like I did before. Because that confused me, and I was like, okay. So then, yeah, we ended up with that and that. Yeah, I think the setup's fine. Crisp. That's always the best part of my day. Oh, nice, nice, yeah. Crisp, crisp, crisp. So wait, Sensation, do you mind if I ask, like, where you're from? Because you said crisp, and usually I hear that in, the UK. I watch too many, like British shows sometimes. So I feel like I have to write a sentence, so... actually, I should write since. Since... I guess there exists an element of X as an element of the real number such that and X is greater than A over 2. That's a messy A. Dang, my A's are like getting, like, my A is like not really like working with me. Okay, now since there exists an X with as an element of the real numbers such that X is minus A, the absolute value of X minus A is less than A over 2, and X is greater than. Okay. So I guess that's it for the proof. Nice. We managed to solve that proof. At least I think so. At least I think so. But it looks like it's solid. Okay. So I guess now I'll just... Did I circle the whole thing? No, I did not. We'll just erase a little bit. Just cosmetic details. There we go. And then circle this part. Okay. So, we managed to get these proofs done. But then again, are the proof structures solid though? I'm just gonna check the answers. So I muted my browser so you guys won't be able to hear it. I just want to see if Mass Sorcerer approved it the way I wrote it. Yeah, so right now he's like going over the definition of an absolute value, which is like, which translates into, which is what we did. Oh, yep, they did the same exact steps. Okay, so they actually did the same thing. Alright, let's see about number 2. So the scratch work he's putting in is basically about the triangle inequality. Okay, now he's going through the duration. Okay. I'm just trying to follow exactly what he did in the proof here. Because there's a slight difference from what he did compared to what I did. Because I want to make sure my logic is, like, right. Let's see, minus b was less than or equal to absolute value, so. Oh yeah, now I remember. So the logic was like a minus b equals 1. That's where, like, I was trying to figure out exactly like where was it that I did differently, and I think I did this part differently. Because I saw that a minus b, the absolute value of a minus b is less than or equal to 1, and then I just put the 1 there. Okay. Now I see what I did. Okay. Alright, so I think that is correct. That is correct. I mean, like everyone that was in the chat with me when I was doing that proof said it was correct, so yeah, that's pretty good. Okay, the last question. Okay, so they did the same scratch work that Penn Center gave that was kind enough to hint to me about. And I apologize if I'm like very, very quiet during this section. I'm just trying to listen exactly to everything that he's explaining. looks like they did like everything that we did in this proof. Okay. Okay, so we just finished like our first section of real analysis. So that's pretty good. So I'll probably do the next section like maybe sometime next week. I'll probably like cover that for myself and just take notes, because I think the next section is introduction to the was it the Archimedean property? So I don't know if I pronounced that right, but that will probably be the next section, but I won't cover that today. So I think now today I'm probably gonna, like right now I'm probably gonna start on vectors, because I feel like I haven't touched like calculus 3 yet, and I probably should touch upon it a little bit. So this on the side here. All right. So right now I'm actually gonna cover, I'm basically gonna use the book that I have with me. Unfortunately I can't put it on my computer, so I have to actually have to flip it through by hand. Because the book I'm using is Student's Guide to Vectors and Tensors by Daniel Flinch. So hopefully, because I actually like this book, because this book is like very like he explains it in a, like it's a bit wordy, but at the same time like he puts the important parts like in boxes and stuff, so it's a little bit easier to follow. Like, I know what a vector is, I just need to remember the operations. So, vector... That seems... Maybe we should zoom in a little bit. I think we need to make it a little bit thicker for the... because it felt too thin to me. Vector... components and operations. There we go. Because obviously a vector can be written like this. We also have the components such as I usually always forget this one rule. Because I get just so into, like, just doing everything. Like, just doing the operations and not thinking about every step. Okay, I know it's break time. I'm just trying to write down the stuff that the graph that I just drew, so that way I can don't have to worry about focusing on it for the next study session. Okay, there we go. Who's... Okay. Hello, Famish? Famish, Dietz, how are you doing? What's the best part of your day so far? Welcome to the Math Spellbook, live stream. Yeah, it's actually, now we're on our, 15-minute break. And then we're gonna do another 45 minutes of study time. Right now we're just, like, doing vectors. Good stuff. Good stuff. Everyone gets edits wrong. Like, what do you mean by that? Just doing some intermediate algebra, not enough math streamers to keep me going. Oh, okay. Like, what do you mean by not enough math streamers to keep you going? Is it like, they go over, like, a lot of, like, stuff that's, like, over, like, the math that you're doing right now? Or is it, like, something more than that? Or is it that you're just saying there's not enough, like, math streamers to, like, basically fill up your, like, follow list? I just like listening in the background, but, I need help, I can just ask away, but it rarely happens. Oh, okay, I see. Well, that too. Okay, that's fine. I actually, like, for me, like, algebra, I haven't done that in a long while, so, like, for me, it's like, I have to actually review some algebra sometimes. But at least you're doing, like, intermediate algebra. Like, intermediate algebra, I think, is, like, it's just a bit cumbersome to actually start learning it sometimes. Because then you have to get used to the rules, and then when you get used to the rules, then you have to basically just, like, do those, like, have to apply the rules in different circumstances. I mean, like, how do you best learn algebra? Do you just basically just do more problems, or do you like applying the algebra to something more than just, like, math? Because, like, for me, I like applying algebra to physics. That's how I probably learn it better. Actually, I memorized the quadratic formula that way. Hey, Penn Center, how's it going? Actually, Penn Center, I'll give you a shout out. So I'll give Penn Center a shout out if you guys want to actually take his linear algebra course or his real analysis like course. Be sure to check Penn Center out. Awesome streamer, very helpful. You are all seeing. Yep, nothing. I guess nothing gets past Famish. Famish, thank you for the follow. Thank you. Always appreciate a fellow, like, math enthusiast. I'm gonna be lurking since I have to clean the house. No problem. Oh, thank you for the follow. AC Cellar? or exceller. Like like I'm trying to read it. Like, tell me if I'm mispronouncing that. Yeah, but be sure to, like, you know, do what you need to do, Penn Center, because I'm pretty sure, like, your lecture, your linear algebra, like, stream was pretty cool, and you probably need to, like, you know, work around some things at home. So don't worry. Thank you for the lurk. Thank you for the lurk. I appreciate it. Right now we're on break time, so, you know, take the time you need. Just clean up everything. Nice to see the math community on Twitch is growing. Yeah, I agree, actually. My name is Exel. Oh, okay, Exel. Okay. I'll be sure to remember that. But it was taken. Oh, okay. That makes sense. That makes sense. But welcome, Exel. Welcome. It's actually funny because I actually have a friend named Exel. Like, not in real life, but, like, he's, like, one of my online friends. Like, he makes YouTube videos and stuff, and, like, wow, it's just funny that you have the same name. But welcome. What was the best part of your day so far, Exel? I mean, like, the thing of it is that I'm actually glad that, like, you know, the math community is growing, because, like, I have another Twitch channel. If you guys want to check out my other Twitch channel, if you like anime or, as well as gacha games, like, you know, that's what my second channel's for. It's mainly when I play games. That's my second channel. That's the channel I actually started with, but then I was like, I want to make a channel that's basically towards my other hobby, which is maths and physics. So I thought, like, why not dedicate a channel to make that? So yeah, that's why I'm basically streaming Math Spellbook. So you can call me Math Spellbook, whatever you like. Math Spellbook. My name is Peter, so, or you can call me Peter, whichever you prefer. I'm currently in French high school, so my day was just going to class. Oh, okay. I see. Well, hopefully you met your friends there, and, like, you know, you guys are just, like, talking, like, basically about your interests and whatever, and just enjoying your school day. Because I remember when I was in school, the best part of my day was just my friends there. Like, every time when I go to class, I'll be like, hey, what's up? You know, that sort of thing. Of course, I was a quiet kid, so, like, I didn't talk much. So whenever I saw my friends, I would be, like, all talkative with them. So you study math and physics on your own or in school? No, so I am a hobbyist. So basically, math and physics are my hobby. I didn't find my love for math and physics until the end of my last semester of university. I have a bachelor's degree in English. So the thing of it is that I took the major, but then I ended up hating it. But I just continued on with it because I was so deep into the major that I didn't want to switch, and I didn't want to make my parents pay for my tuition, like, for me to stay longer in school, so I decided not to do that. So yeah, I ended up loving math and physics, like, later on in life. So I thought, like, you know, why not dedicate a channel just to basically, like, support my hobby? You know, I'm already, like, 34 years old, so, you know, like, I thought, why not a better time to get into math, you know? If I was lucky to actually make a lot of money, then I would probably go back to school just to get a bachelor's in both physics and mathematics, because I just love it. But at the same time, I don't want to be working a job while I'm studying math and physics. I'd rather just, like, the only time I would want to be rich is if, like, I'm rich and I can support myself and I have income coming in, and then I could just go to school and I can focus on school. Focus on learning things. But of course, like, I would say I'm a full, I guess, like, because I'm not working, I guess I would consider myself as a full-time content creator, because I'm just making content for you guys, even though I'm not making money from it, you know? Penn and all those wonderful people got me liking math. Nice. That's good. It's always great to have a community that inspires you. You know, like, I've seen Penn streams and I'm like, wow, he is very, very good. And, you know, like, whenever I watch any math streamers, I feel like I'm, like, the dumbest one in the chat. But then again, I embrace that because it shows that I have a lot to learn. In addition, it's like, wow, there's so much wisdom that these streamers can give me about mathematics or physics, you know. And, you know, like, you know, all you guys in the chat, like, some of you are in school and some of you guys are just, like, trying to learn math or physics, like, you know, for either your assignments, or maybe you just like math and physics and you just basically just want to learn it. and you know, you just didn't want to pay the money to go to a university, so it's like, you know what, I'm actually going to go to some content creators that actually are talking about this stuff, you know. And that's the best alternative, like learning online. And I think a lot of people will be learning online a lot more, because like I know when people go to school they start losing their interest in education because like it just becomes so tedious, because you have to do homework and you have to do tests and stuff, and it's like, can I learn something that inspires me and makes me feel like it's interesting and cool? And then like you start educating yourself if you're lucky enough to read books about the stuff that is like kind of complex, and then you're like, I want to learn enough so I can get to that part. In France, we have a lot of public universities, even the best ones. It's hard to get accepted in, but generally, it's generally free or cheap. That's pretty good. That's the thing I like about Europe, is that like some of the countries, they allow you to go to university for free. It's just that it's just a tough entrance exam. I'm pretty sure that Japan and Korea work the same way, but at the same time, I think you have to pay for university for those countries. But yeah, like I plan to get a math certificate or degree of my second year. Nice, Famish. I wish you luck on that. You know, like it's so cool that like when I started this channel, like I started this channel not like a few days ago, and like all you guys just started like coming in and like giving me such warm welcomes into the math community. And you know, like I always love the positive vibes that you guys give off, because it shows that there are people like me who love math and physics like with like a big passion, because like in my real life friend group, none of my friends are into those subjects, and I only know up to calculus like 1 to 2. Like 2 I have to review a lot because I haven't done calculus 2 in a long time, so I have to like learn to like practice more on integration techniques and series test. And I never even did Taylor series, which is like unfortunate, because like my class was a summer class and we didn't have time to cover Taylor series. So I'm guessing like all you guys are like practically in school, like basically just taking classes, right? Like, are you guys like in high school, university? What are you guys up to in your academic adventures? Okay, we got like a minute left in break, so I will still answer your questions, but I would still like reply to what you guys put in chat. Because like the thing of it is that like I think because usually I try to do 2 study sessions, so 2 45-minute study sessions, and then like I just basically take 15-minute breaks like after those. I'm in my last year of high school. Nice. So I wish you luck, because like senior year of high school is like pretty much a big thing, because it shows that you're going to university and trying to do big things. Do you know what you plan to major in when you get to university? Okay, we got 10 seconds left. I'm just gonna turn off the study timer when it hits 1, because that way we can start it over when we're ready. Okay. Yeah, I'm in online school studying computer information systems for my associate's degree, but I'm thinking of attending a community college for math. Oh, that's great. That's great. Actually, like one of my old college friends, like he majored in bio, and graduated with a bachelor's in bio, but now he's going back to school for an associate's in computer science. So, you know, like he's practically on the same path that you're on. But at the same time, like I don't think he's planning to like major in math or anything, because whenever I show him like ideas in math and physics, he says like that's above my pay grade. So I will be right back, guys. So I'm just gonna run to the bathroom for a quick second. So be right back, and then we'll continue on with the next study session. Okay guys, I'm back. Sorry to keep you guys waiting. So, let's get into continuing on with the next study session. So, right now, we're covering vectors. I was doing, like, proofs from, like, real analysis before, but, like, after I finished, like, 3 proofs, I was like, okay, now to do some calculation-based math. So I thought I would just get into vectors. So, I'm going to start the study session right now, so if you really need to get something done, like homework or whatever, or you're just doing a project on your computer, or like maybe you have some chores to do, you are more than free to do so. And if you want to type stuff in the chat, I will get to it when I see it. So don't worry, I'm here with you. Even though it's a bit of a study session, it's not really meant to be like we're in a library and you guys are meant to be quiet or anything like that. It's mainly just like a hangout study session where it's like, oh, we're just chilling together and we're just basically trying to focus on like boosting our knowledge. All right, I will start the study timer right now. Gotta click on my tablet screen. Oh, sorry if you hear that buzzing. That was from my fan. It just caught my mouse cable. Okay. Because sometimes with my tablet, I have to make sure that when I have to click on it so that it just does what I want it to do. I want to make sure. Okay, so these are the unit vectors for polar coordinates. Do I want to move to the side or do I want to move it to the... Actually, let's move it on the side. Why not? So now we're just basically doing different coordinate systems. That should be fun, right? Okay, now we gotta do cylindrical coordinates. So dot dot. Luckily, cylindrical coordinates are almost similar to polar coordinates. I think it's when it gets to spherical coordinates that's when it gets a little bit chaotic. Well, not chaotic. I think it's just a lot more memorization. So a research mathematician? Nah. Let's see. I'm just trying to catch up on what you guys typed in chat because I saw you guys typed more. Yeah, tech is growing fast. Good career unless AI takes over, but it won't happen for a while. Yeah, not like I would say AI won't be fully implemented until like maybe past 2030. So I think we have plenty of time before the AIs basically kind of like implement themselves in society. But I'm not afraid of that. I'm not afraid of that at all. Let's see, I would like to get into a preparatory class to get accepted into a named school named ENS to become a researcher in mathematics. Oh, a mathematics researcher. That's tough because you have to get your PhD for that. But I wish you the best of luck for that because, you know, like, honestly, if money wasn't an object of that, like if money was no object, I probably would have like done the same thing, like become a mathematician or a mathematical physicist. Because it's like, I don't know why I like mathematical physics. It's just like something in me. I guess it's that feeling from the universe where it's like your body is telling you, yes, do this, do this. Like, it's that gut feeling that tells you this is right. I guess I like mathematical physics because it just implements both of my hobbies at once. But I don't know enough math to actually get up to that level yet. Not yet, anyway. Always remember to put the yet part. Oops, no. Do this. And then that's sine, right? Yep, that's sine. And then z remains the same. Not a problem. Okay, now we gotta sketch the diagram so I remember which angles is which. Bring out the ruler. Drag it over here. And then we gotta do it 90 degrees. And then we'll just do that. Oops. And then for the, we'll turn it, I think we'll turn it 45 degrees because we have to do a 3D model. Do here and do 0 degrees right here, and then we go. There we go. Now we gotta make a little small angle here. Let's do like that, yeah. So draw that, like that. I think we gotta do another 90 here, so we can just draw stuff right. Okay, drag that right here. Draw it a little bit like that. Then then we'll turn this to the same way we had it before. I probably should have done these bottom ones like, which way was this one? This one was close to 17 degrees. Okay, so we'll just do it that way. And then draw that like that. I think we'll just make this 0 degrees for the other side here. Then draw it like this. Hopefully that's, yeah, that looks about right. Then we'll just turn this another 90 degrees. Then we'll just draw this down like that. Perfect. Then we'll just draw a small curve here like so. Make it look a little nice. And so this angle right here should be like that. And then this part here is, that's the point where it's like P, C, so it's like that. And this is R. So R is pointing out this way. I'm not gonna pull out the ruler again. I'm just gonna like draw the angle, draw the arrow here. So this is our hat, and this side is supposed to be phi hat, and up here right, and then we got the z-axis up here, then we got the y-axis and the x-axis. I actually made the x-axis too long, but that's okay. That's okay. It's all for the sake of making our stuff look nice. So looking over at the, usually the unit vectors for the other coordinates I haven't fully like mastered. So for, okay, so I guess the easy way for me to remember the unit vectors for the polar coordinates is just think of the derivatives. So basically cosine is like cosine and sine are basically for the r hat, and then basically like for theta hat, we have to remember that the derivative of cosine is negative sine. Yeah, negative sine, and the derivative of sine is just cosine. Okay, that's probably an easy way to memorize it. Okay, let's get to the unit vectors of the spherical, no, the cylindrical coordinates. Mm. So I think I'll write them on the bottom here. So we'll just drag this over here like that. And then we'll write, yeah, actually I made the x-axis too long. I probably should like just minimize that because that's gonna annoy me. Yeah, just make it like that. Make it much easier to write. Okay, now time for the unit vectors. So we'll just write cylindrical unit vectors just so that we don't get confused in the note-taking process. And I think like next week we'll probably go back to using vectors, yeah. Because I don't plan to stream on Thursday or Friday on this channel. So like if you guys want to know the schedule, it's like down in the about panel. So what book are you using to review these? So the book I am using, it is Student's Guide to Vectors and Tensors by Daniel Fletch. I think that's his name. So what I like about this book is that I actually got pretty far in this book. I just haven't picked it up in a long time, so I feel like I have to actually review stuff. But the thing I like about this book is that the author made a website on where the answers are for the questions. So it's like a very easy access book, which I really like. And it goes from vectors to tensors, and I think I really want to finish this book because I think I got up to the point where it was like we were starting to introduce like what is it? Covariant and covariant and I think quadrivariant components, and that was the part in the book that I kind of felt like I didn't fully understand. So that's why I'm actually trying to get back into this book, because I think once I get to the part in tensors, I'll be like, ooh, this is going to be fun. Because I always wanted to learn tensors, because once you learn tensors, you learn a little bit of the math behind general relativity. And mostly I think tensors are used in like a lot of areas in physics. So that's why I want to learn tensors. Because most of you guys are like into computer science, right? I'm guessing. Okay, I hope I'm writing this right. Cosine. Oh, okay, so it's similar to the polar coordinates. Okay, that makes it much easier to remember. Yeah. Perfect. Okay, now on to the next part, which is spherical coordinates. Spherical coordinates. Oh boy, this is going to be fun. Because spherical coordinates, I just don't memorize that well. I think that one is the one I have to practice the most. Spherical coordinates. I think a majority of the study session, if we don't get to the questions. Oh, it looks like we're gonna get to the questions pretty soon. Okay, that's cool. Alright, so now we gotta actually like write the coordinates for these. So we wrote the, okay, that's, okay, cool. I wanna make sure that we didn't miss anything. Okay, for spherical coordinates, right, so spherical coordinates, we have r square root of x squared plus y squared plus c squared, then theta. I'm actually looking forward to when AI is like takes away like the stuff that humans don't want to do, so humans can actually focus on the things that they would like to do. But then again, I understand why people don't like AI, because they're worried that jobs will be taken. That's also another fear and concern. But I would like AI to make our lives like a little bit easier so we don't have to worry about other things. It's kind of like a thrilling future to look forward to, I think, because once technology kind of makes our lives easier, we can focus our energy on the things that we find most important. But then again, like people that are not well versed in like, you know, like electronics or technology, they get left behind, which is unfortunate. Sine, and then Z R cosine theta. Okay, now the fun part, to actually do this graph. So do this. Yeah, we'll just go down here. And then turn this angle right here. Maybe another 45 degrees. Yeah, there we go. 45 degrees. Draw it like that. Oops. Then 0 degrees. Like that. Let's do it like this. Not too close, but not too far either. Okay, so it's mostly curves, so... Oh, no. I want the ruler to extend. So I think we can do it like... this. To just draw that there. I think we gotta make this line a little bit longer. Let's do it up to there. Okay, perfect. Alright, turn that off. Now we gotta just draw this really nice curve. Oh, oops. Try to draw like a nice curve here. That wasn't really nice. It's not very nice. Let's just erase this a little bit. Because I'm left-handed, so that's why it's like kind of like etchy like that. Okay. Do that. And then we'll just bring this curve up here. And then this curve up here. Well, they're supposed to be connecting. That'll work on like lining up the lines. And then bringing this curve down here. Then I think there's a point here. So I'm gonna do it like this. And then we have this little fold here. And then bring that up there. So we have theta, which is up here. I think that's rho. And then we have this one is phi or phi. And then here, like this point here will be the point r theta and phi. Then we have arrows pointing out. That is r hat. I think to this side here is phi hat. And I think down this line here is theta hat. Okay, so we have some notes here. So cone of constant theta and sphere of constant r and plane of constant v. Okay. All right. I'm just wondering what this row is for, though. Maybe it's like the line that connects that connects the origin to the point. Okay, so I think now we got to go into the unit vectors. Now these unit vectors, I never could memorize these. Spherical unit vectors. Oh, forgot to put an S on that one. All right, so r hat is equal to sine of theta times cosine of phi or phi, sine of plus cosine of theta k hat. All right, so it's cosine of theta times cosine of phi. Oh, that doesn't look nice. There we go. Cosine of theta sine of phi minus the sine of theta k hat. Hopefully you guys are doing well on whatever it is you guys are doing. Whatever projects or whatever things that you're got going on. Cosine of... Okay. Alright. Let's see if we can try to like create a system to memorize this. I doubt it. I'll probably forget it. Let's see. We have sine theta cosine of phi plus sine theta sine phi and then plus cosine theta. So this one is cosine theta cosine phi plus cosine theta times sine of phi and then minus sine. Now that I'm thinking about, don't memorize. Hello, Tyrion. You can always look them up. Oh, okay. Hopefully I pronounced your name right. It's Tyrion, right? Is it Tyrion? Or Tyrion? I probably said the same thing twice. Derive things is more important if you need it. Okay. Either? Okay. But how you doing? What's the best part of your day so far, Tyrion? And thank you for the encouragement, because I hate memorizing. At the same time, like, I feel like I just came up with the idea of, like, actually how to better remember this. Let's see. So, because I'm thinking that these are derivatives of one another in some way. Because, yeah, sine is the derivative, cosine is the derivative of sine. Yeah. Sine is, yeah, so sine is the derivative, so the derivative of sine is cosine. Yeah, and then cosine, basically the derivative of that is sine, a negative sine. let's see, sine, cosine, yeah, so I gotta figure out how to derive these, like basically on first, they are orthogonal to each other, okay. The thing is that I gotta think of a way to actually remember, the first part, like basically r hat, and then I would probably say like, okay, I just have to take the derivative of like it to get to the second one, which is theta hat, and then let's see, phi hat. Check this out. What is this? What is this link? Oh, here we go. Interesting. Thank you for that reference, Tyrion. I really appreciate it, actually. I'll just save that in my book. I'll just bookmark that so I can look this up. Okay. Actually, Tyrion, I'm wondering, like, are you a student right now, or are you doing it as a hobby, doing math or physics as a hobby, or you're just like, you know, like you just already like working somewhere else that doesn't have anything to do with both subjects? And it has derivations for the basic vectors. No, I graduated a long time ago. Oh, I see. What are you doing now? If you don't mind me asking. Like, whether it be career related or just at this moment. Okay, I think I'll just read this like a little bit later, but thank you for the link. I appreciate it. Yes, I'm working on something different, programming for a living. Oh, nice. Like, I actually tried to learn C++, like when I tried to go back for school for engineering. I don't know how programmers do it. I always feel like it was kind of boring for me. Like, just sitting there and just typing stuff up. But then again, I didn't try creating stuff with C++, so maybe I should have tried to create something. Because I did try to learn Manum, which is the same language that 3 Blue 1 Brown uses to animate his videos on YouTube. I tried to learn Manum. I think I got to a certain point, but then I just ended up dropping it because I got bored with it. Programming is a competitive job. I don't know of. I'm get a tech job. Oh, okay. Well, I wish you luck with that, Famish. Unless you already have a tech job, then, like, you know, hopefully you're working on something that is pretty cool. Okay, so we already wrote those down. Basis vectors. Oh, not basic, basis. Basis vectors. Basis vectors. Oops. Vectors. It helps when you write scripts for folks. You can't really write scripts. Makes it interesting. Actually, what I recommend for you. Learn curvilinear systems. Let me find one of my links. Oh, okay, no problem. Because I think I saw that in like a theoretical physics book. Curvilinear systems. I think I saw that in a theoretical physics book that I bought one time. Oh yeah, these look really cool. Yeah, I would actually like to learn this stuff. Actually, this looks pretty cool. Because the thing is that like I'm still trying to understand with vector coordinates, such as quadravariant and covariant coordinate systems. I'm trying to better understand that. Basically, you can derive all of these guys from a general formula, no memorization. Oh, okay. What is it? Is it like derived from the what is it? I had the name in my head. The Pythagorean theorem, or is it like derived from like something else? Let's see, quantum mechanics, general relativity. That's the stuff I want to get into. You do the generic orthogonal in 3D. Oh, okay. Well, you seem to know a lot, Tyrion. Thank you for sharing this knowledge with us. I really appreciate it, actually. Because my goal is, like, for all you guys that are new, my goal with this channel, or at least like for myself, including this channel, is that I want to be able to learn enough physics for, to be able to understand this book. The Road to Reality by Roger Penrose. And there's like another book I would always show to everybody whenever I'm trying to say, I guess, the quote-unquote goals of this channel. Mathematical methods. Oops. There it is. There it is. So I want to be able to understand these books. The Road to Reality by Roger Penrose and the Mathematical Methods for Physics and Engineers. I want to make a physics engine. Oh, take care, Axel. Thank you for coming into the channel. I'll watch your channel with attention and look after the previous videos. Oh, okay. So Axel, like, if you want to catch up, what you missed, you can. I'm going to upload this VOD onto YouTube because since I'm not affiliate yet, my VODs only stay for like about a week. So I will upload this VOD onto YouTube if you don't get a chance to watch it like within 7 days. And you guys can give my YouTube channel a subscribe if you like, want to catch up with like what I'm doing on the daily. But yeah, like I really want to be able to understand these books. This one, like it seems like it's both challenging but also tame at the same time because they also show preliminary algebra, but there's some techniques that I'm not used to seeing in this book, especially in the algebra section. Because it seems like it's meant for people that actually are used to mathematics, that have thought deeply about these ideas, and I only know like the basic stuff. Yeah, and if you guys are new here, like, you know, if you're lurking, thank you for the lurks. But yeah, like I said, my name is Peter. Basically, welcome to Math Spellbook. If you want to be productive in doing whatever it is you're doing, it doesn't have to be math. It could be just like you doing an art project or you programming stuff or just writing code for something, whether it be for work related or like for college or something like that, or even just for school. Like, you know, I just want to be able to give you guys the vibes of just basically just being productive at your own thing. You know? Okay, let's get into basis vectors. Like, I know what basis vectors are because I know unit vectors, they can be basis vectors, but not every basis vector is a unit vector. That took me a while to get used to. I couldn't put my head around it until I actually had to, like, think about it, and I was like, oh, okay, that makes a lot more sense. Oops. That's not a hat. It's an arrow. 1? 2? Actually, I like the 3 blue 1 brown music. It's so calming. And plus it gives like that study vibe where it's like you're on the verge of like discovering something. But it's like playful. What do we got here? This is not trivial, but check it out. You will see towards the end, derived spherical or whatever base on generic. Ooh, okay. Thank you, Tyrion. You're actually making learning a lot more fun for me. Actually, I should move these onto my other screen so they don't interrupt the flow. But thank you for the link. I will actually bookmark it so that way I can give it a read. See, this is why I like being able to like make friends with you guys, because you guys are just so brilliant at what you're doing. Like, you just find like, nah, like I don't want to memorize stuff. I'm actually going to get to the hardcore of what I need to actually like understand for this stuff. Bases are not length 1 necessarily. Yeah, but like the thing of it is that the way I remember what a basis vector is compared to a unit vector is that I know unit vectors are usually just 1 unit away, but I know that not every basis vector is like 1 length. So I know that basis vector unit vectors can be basis vectors, but it's not the other way around. Like, that was how I was able to, like, I guess, understand what a basis vector is. Because before I would thought that unit vectors and basis vectors were the same thing, but then I had to like think about it, because like there were different times when basis vectors were totally different, like totally different from like 1 unit, and I was like, okay, so how can I better understand this? And the way I was able to understand it was that unit vectors can be basis vectors, but basis vectors are not always unit vectors. That was like the best way for me to memorize it in my head. Right, yeah. Because basis vectors include unit vectors, but it's not like every basis vector is a unit vector, right? But thank you for like clarifying that with me. Like, that was the best way I could actually like formulate it in my head, so I actually understood what a basis vector was compared to a unit vector. This is why I love it when people are smarter than me, because I'm like, oh my gosh, like they have so much knowledge and so many tricks that they can implement to me and like teach me. So what did I miss here? So we got the basis. So for a vector, actually, like, because of this book, it made me feel like I have to get back into linear algebra too. And if it sounds like I have something in my mouth, I have a cough drop in my mouth, so I apologize if you guys can't understand what I'm saying. It's because I talk a lot more on this stream than my other stream sometimes, because, like, you know, we're talking about math and physics. But if I'm disturbing the flow of your studying or your programming or whatever it is you're doing, you can mute me if you want. I just love learning, especially when it comes to like math and physics. Experience is not more smart. Well, yeah, because experience develops like intelligence into wisdom. I just say smart for like all categories, like, you know, more experience, more more knowledge. Like, whenever I say smart, I usually mean like everything. Like, I mean like experience as well as like knowledge as well. Yes, I do have that book, actually. I do have Linear Algebra Done Right. The author put his book up for free. Yeah, I actually even bought a copy of the book. Because, like, for me, I always wanted to be hardcore about, like, because I would always study in the morning. Whether I be just reading a book or whether I do problems. So I always love having the physical copy with me. But of course, like, you know, books take up space, so unfortunately I can't have every single book. But I do have that book. I know what book you're talking about. I still have to understand what vector spaces are, because I feel like I have a vague idea of what they are, but at the same time, like, I don't, like, I feel like I just don't have, like, the full understanding of exactly how they work. If that makes sense. Um, so basis vectors are... Well, actually, I should just write details so I don't get confused. Okay, so we got the original coordinate system. Which is x. Okay. And the new system, well, actually I should put new coordinate system. That makes it easier. New coordinate system. That is x1 prime, x2 prime, and x3 prime. Let's just drag down here. And so the basis vectors, okay, basis vectors from along the original and written in the new system. So along, I should probably put like bullet points here so that way I know what they are so I don't like miss them. Along the original written in the new system. Okay. Let's see what you... Well, part of the issue is the word vector in vector spaces. It is a bit confusing when you try to relate the arrow concept of vectors, but basically it is a group of objects with certain properties, vector spaces. Yeah, because I know when I think of vector spaces, like I know it's just a category of rules of what vectors can do. Like it has to have like, you know, the identity vector, which brings it back to like what brings it back to I think its original vector, and then it has to have the zero vector. You have to be able to do scalar multiplication with it and vector addition with it. So basically it's just like something that tells vectors what to do. I mean, that's my general consensus on that. But if I'm missing any details, please let me know. I think like I just haven't practiced problems where it says like prove that this is a vector space. I would have to actually like relearn that. And I think eigenvalues and eigenvectors, like I haven't done many problems with those either. So I got a lot of practice with the math that I haven't done. So I think this session will probably be a lot of note-taking. Maybe, I think next week we'll probably do the problems in the book. Because, like, after this section, it's just basically the problems from chapter 1. And the best thing about this book is that it does implement some ideas from physics with vectors, so can't wait to do that chapter. So the bottom parts are all like... I always love the scenes where like it shows like scientists or mathematicians or just geniuses writing on a board talking about a big idea within like math or physics or anything in general, like, you know, like a big idea. Like I think one of the clips I would watch a lot is like that, I think a scene from Star Trek where it's like one of the one of the crew is like basically trying to learn like I think quantum quantum chromodynamics, I think, and they were trying to like learn it with Einstein, like a program of Einstein. I mean, equations on a board just looks really, really beautiful to me, but like some people will be like, no, I don't want to touch that. Which is understandable, because it is kind of a mess. Okay. So there we go. So in other words, the partial derivatives of the new basis vectors are practically for the original bit. So probably should write that as a note. Alright, I know it's break time, but I just want to write this final note here. Partial derivatives see here. Okay, write that here. Oops, that's a 3. Okay, our components of the first original unprimed basis vector expressed in the new primed coordinate system. For this reason, you'll find that some authors desire basis vectors in terms of partial derivatives. These relationships will prove to be extremely valuable in the study of coordinate system transformations and tensor analysis. So file them away in your studies. Include those topics. Okay. Alright, so the next part of this book is basically chapter 1's problems. So we will probably do those next week. But that was fun being able to like engage that with you guys. Let's see how much we have in notes. So far, like the whole of chapter 1 is basically all this. I mean, there was more stuff in chapter 1, but it's basically the basics of like vectors in general. So like that's like I already know things like the dot product and the and the cross product and stuff. But I think those will come later. The only thing is that getting the coordinate systems down, that's the thing that I struggle with mostly. Because once I'm able to like fully like know how to get them from like a basic understanding, and thank you Tyrion for giving me all those links, because I will definitely read them so that I can better like understand by deriving these coordinate systems. That will actually like help me a lot. Let's see here. The basis vectors, I just want to be able to like fully understand this. Like, so it's like the basis vectors are the derivatives, the partial derivatives of like the original, of the new basis with the original. Okay. So it looks like you have to put the original one, the partial derivative to the original one on the bottom. Okay. So I'm guessing in order to get to the new system, you have to do the opposite. Okay. That looks fun. Okay. So that's practically pretty good for today's stream. So like I said, guys, I will be posting this VOD on my YouTube channel. So because like since I am not an affiliate yet on this channel, I will be uploading my VODs there. So if you guys like miss a VOD, you can basically just go there and basically like, you know, check out the VODs there. If there was something I did in this stream and you basically weren't able to catch it, like, you know, like a certain topic or a certain like idea that kind of was like, oh, that's related to the problem that I was doing, but then you weren't able to stay, like, it's like, oh dang, I gotta leave, but I want to see the solution. It will be on YouTube, so don't worry. I'll be uploading these VODs on YouTube, so that way you don't miss a thing concerning that. Anyway, I also am planning to stream tonight on my other channel, so if you guys want to check out my other channel, Uncle Talks, you're more than happy to do so. In that channel, I basically just game and basically like talk about anime or anything that is intrigued to me. I actually talk more on this stream than in that one, because you know, like with game content out there, sometimes my chat is not very active, so sometimes I just focus on the game that I'm playing. But I do try to talk to you guys once in a while I'm there. It's not like I'm not very talkative there. It's just that sometimes like I've run out of things to talk about. With math and physics, sometimes I just don't run out of things to talk about because I feel like I have so many questions related to the topics. So, but yeah, I think that will do it for today's stream. I wonder if there's anyone that's streaming math content. Maybe we'll give them a raid. Let's see. I mean, Labyrinth is doing a work study stream, so basically we can probably give her a raid. So we'll do the raid message. So you guys are free to copy and paste that if you like. I actually made it. So you're free to copy and paste that if you like. I'll just do that again just in case, because sometimes I miss out. So we'll do that. And we'll just do the raid command. So Labyrinth. Okay guys, I'm going to end stream for now and we'll raid into Labyrinth's channel. So if you guys still want to study or still want to be productive, you can continue on doing what you're doing on when we raid into her channel. So always remember, as I said say to you in both channels, everyone is precious. You guys are just as precious as everyone else, and I will see you guys on Labyrinth's channel. So take care guys. Bye-bye.